Hey everybody, so today we're going to take a look at parallel and perpendicular lines and their relationship with slope. So I'm going to go ahead and give you a heads up of a couple things. First of all, I apologize that these notes are probably going to be long, but there's a lot to cover, and I want to make sure you have a good example of everything so that you'll be better prepared for your exams and what we got to do in class. Secondly, I apologize that I'm using a pencil when I do this. However, I don't have my cheat sheet today. I don't know where I put it. I had this all worked out so I could, if I got stuck or forgot the answer or something, I could look at it real quick. But I can't find it, so I'm just going to wing it, and we're going to see how well I do. So first, we just got some fill-in-the-blank stuff. Parallel lines exist on the same plane and never, ever intersect. They don't touch. That's why the symbol for parallel is two lines going straight up that never ever intersect. That's the symbol for parallel. Perpendicular lines also exist on the same plane, and they intersect at right angles. Okay, if the special thing about parallel lines is they don't intersect, then of course perpendicular lines intersect. In fact, all other lines on a plane intersect. They just intersect. Except perpendicular lines, they intersect at right angles. In fact, the symbol for perpendicular is this. It's an upside down T. It creates these two right angles there. So in my class, at least, you need to check with your math teacher. You never have to write the word parallel again. You can just give me the symbol. And you never have to write the word perpendicular again. You can just give me the symbol. Now, if two lines are not parallel and also don't intersect, then they do not exist on the same plane. These are called skew lines. If lines don't intersect and they're not parallel, then they have to be on a different plane. And if they're on a different plane and they don't intersect and all that stuff, it's called a skew set of lines. So this part may take a minute depending on how well you plot points, but we need to plot these points, connect the dots, and label the lines. So we got negative 2, 5 would be negative 2, 1, 2, 3, 4, 5, and negative 5, 1, 1, 2, 3, 4, 5, 1. Now, that is going to be a straight line. I'll line that up just right. And connect the dots. I'm going to go from one side to the other. Hope this is showing up well. I usually don't like using pencil because it doesn't show up very well. Line B is going to be negative 7, 3. So that's negative 5, 1, 2, 1, 2, 3, and negative 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. There's my next line. Oh, I'm sorry, I forgot. This is line A. This is going to be line B. Line C is going to be at negative 1, and negative 5, 2. Negative 5, 2 is going to be right there. Ooh, that's close to the other one. So now I'm going to draw this one. Alright, and this one, that's line C. And then line D is going to be at 1, 1, and 3, negative 4. Ooh, way down there. Alright, so I'm going to connect these. Excuse me. That is going to be line D. Let me do it here. Okay, so that's line D. So, here's the thing. Line A and line B are supposed to be parallel. That's what a parallel set of lines looks like. This line is parallel to this line. If you look, to get from here to here, you go up 1, 2, 3, 4, and over 3. To get from here to here, you go up 1, 2, 3, 4, and over 3. They have the same slope. Parallel lines have the same slope. In fact, let's jump ahead. Parallel lines have the same slope. Okay? Line A and C are perpendicular. I'm spelling the word out. If you want to you want to put the symbol, go ahead. And also B and C are perpendicular. Okay? And if you look here, to get from here to this point, I go up 1, 2, 3, and over 1, 2, 3, 4. See, and they make right angles right here. See, that's a right angle, and that's a right angle. All right. This slope is different. This was 4 over 3, and it was a positive slope. This is 3 over 4, and it's a negative slope. That's because, down here at the bottom, perpendicular lines have slopes that are flipped and opposite. Okay, flipped means the fraction will be flipped over. Okay, and opposite means one's going to be positive, one's going to be negative. So see, that's positive, and this one's negative. And then line D is just intersecting. It is not parallel to them. It just goes through all of them, and that is certainly not a right angle right there. Okay, so this line just goes through all the other lines. And then line E is skew. And you're like, where's line E? Oh, line E was way over here. See it? That's line E. Line E is on a whole other plane, and it's not parallel, perpendicular to these or anything. This is on a totally different plane. So it is skew. Now, to check it out, parallel lines have the same slopes. These are some examples of same slopes. See, 3x plus 3, 3x minus 7. This one and this one, they actually do have the same slope. If you solve this, you would find that the new equation would be y equals, give me a second here, you did this yesterday in your, on Thursday night's notes and Thursday during work. It'd be y equals, this is why I have a cheat sheet, 3 over 2x minus 7. And this one would be y equals, x over 7 halves. The second part really doesn't matter. It's 3 over 2, that's the slope. And this is going to be 3 over 2 x minus 3/4. Okay, so see, 3 over 2, 3 over 2. The slope is the same. On this one, it's -1 and -1. That's the slope. On this one, the slope, y equals 4, that is actually a slope that looks like this. That's y equals 4. And this is y equals -8 down here. But those slopes would be parallel. This actually has 0 slope. There's no x. This one, x is 3. And this one, x is 8. That actually goes straight up and down, like this. That's what's known as, I'm sorry, you can't even see my picture. This goes straight up and down, like that and like that. That is, if you remember from yesterday, that's what's known as, that's 0 slope. This is undefined slope. That's the word I was looking for, sorry. Now, flipped and opposite. See, this is -3/4, and now it's +4/3. And this one is 1 over 4. This is -4. Well, it's -4 over 1 if you want to think of it like that, but you don't have to put the over 1. So 1/4, if you flip it, you get 4 over 1, and since that's positive, that one has to be negative. This is -1, so this is +1. You're like, well, that's not flipped. Well, this is really -1 over 1, so this is really +1 over 1. If I flip 1 over 1, I still get 1 over 1. It still works. This one is like this, and this one is like that. I promise, if I solve these, you would have well, I'll solve it. So this one ends up being y equals 3 over 2x minus 7 over 2. And this one ends up being y equals negative 2 over 3 x plus 1/2. That's what that ends up being. So you can see 3 over 2, negative 2 over 3. So see, until you simplify these into point-slope form like that, you're not going to know for sure if it does. And by the way, these are also perpendicular. Y equals 4 looks like this. X equals negative 8 looks like this. And that's a right angle right there. Those would be perpendicular. Okay. On the back, all right, we're 11 minutes in. I'm not doing too bad. On the back, we're going to look at this table. So if they are perpendicular, they're going to be flipped and opposite. If they're parallel, they're going to be the same. So, man, I can fill most of these first two columns out real quick, because if that's 3/4, so is this. And if that's negative 4/3, so is this. And if that's negative 5, so is this. And if that's 1/2, so is this. And if that's negative 12/13, this is negative 12/13. And if that's 0, so is that. Okay, because all of these are going to be the same. If this is the slope of one line, your parallel slope is going to be the same. The perpendicular slope is going to be the slope flipped and opposite. So I'm going to flip this and make it the opposite. So I'm going to flip this, and make it the opposite. So it's positive now. Oh, this and that is, okay, it's just the opposite of those. Okay. This one, to go from here to here, I've got to flip it and make it the opposite. Now I can do this one, negative 7 over 6. Remember that negative 5, if you need to flip it, think of it, it's negative 5 over 1. So I'm going to flip it 1/5, and I'm going to make it the opposite. So since that's negative, that's going to stay positive. 1/2 is going to be 2 over 1, or just 2. And because that's positive, this one's negative. Okay. To get from here to here, I flip it, so it's 6 over 5. And you make it the opposite. So since it's negative, that one's positive. And so is this one. To get from here to here, you flip it, and you make it the opposite. So that one's going to be negative, so that one's positive. Now for that one. All right, we talked about this yesterday on our notes. Zero slope. If you have a coordinate plane, zero slope looks like this. The perpendicular line to that looks like this. Okay? This is a y equals, this is an x equals. But that didn't tell me the slope. The slope of this, well, you remember what that slope is? What is that slope if you have a line that goes straight up and down like that? And the word is undefined. That is undefined slope. Alright, so this is a very common problem that you have to solve. Are these going to be parallel, perpendicular, or just intersecting? Okay, so we have to do what we've been doing. We have to, what we did yesterday with our slope problems. We've got to solve for y. We need it to be y equals something. Okay, so when I solve for y on this one, first thing I do is I move the 2x over here. So my new problem would be negative 7y equals negative 42 minus 2x. I subtract 2x on both sides. The next thing I'm going to do is divide everything by negative 7. Y is going to equal this divided by negative 7 and this divided by negative 7. So negative 2x divided by negative 7. Now, to simplify this, you can simplify this part if you want to, and the answer is going to be positive 6, and that's fine. But I'm going to tell you that if it doesn't have the x with it, we really don't even need this. This is the only thing we're really concerned with. And this slope, negative 2 divided by negative 7, the two negatives are going to make a positive, and it's just going to stay 2 over 7. That's our slope. So now we got to do this one. And this one's not going to be too difficult. This is going to be 4y. The first thing I'm going to do is divide both sides by 4. And so when I divide this side by 4, it just becomes y. When I divide this side by 4, I get negative 7x over 4. And I divide this side by 4, this thing by 4, I get negative 2 divided by 4. And to simplify that, I can't. I cannot simplify that. That stays the same. So that is going to be y equals negative 7/4 x, but I can simplify that. Instead of minus 2/4, it's going to be minus a half. But guys, that's my slope. These slopes are not the same, so they are not parallel. But they're also not flipped or opposite. Flipped and opposite. They're opposites. One's positive, one's negative. But they're not flipped. It would be 7/2. Negative 7/2 would be flipped. So these just intersect. That's what these do. As for these, we just talked about this. If we have a slope y equals 3, that would look like this. And we have a slope x equals negative 2, that would look like this. And guys, those slopes are perpendicular. That's the answer. The answer is perpendicular. And then over here, we got to solve these. I'm betting these are parallel, but I could be wrong. So when I solve this first one, the first thing I do is move 2x over to this side. So I would get 5y equals negative 1 minus 2x. Then I divide everything by 5, so y equals negative 1/5 minus 2/5 x. This is my slope. On this one, I would just divide everything by 10. So y would equal negative 4/10x minus 20/10. So this would become 4 divided by 10. 4/10 reduces to 2/5. And 20 divided by 10 is 2. But again, oh sorry, the x should be there. This is my slope. Negative 2/5, negative 2/5. These are parallel. Okay? And right here, the slope-intercept form of the equation of this line describes. So, there is this trick, this thing that you learned in algebra. I know it's been a while. We have this one line, this line here. We need another line that is parallel to this line that goes through this point. So, we know that in this line, my slope is negative 1. That's my slope. Remember, slope is m. m is negative 1. I want it to be parallel, so my slope is still going to be negative 1. I need it to go through this point. Well, there's this formula we had, and it looks something like this. Y minus y1 equals m times x minus x1. It's been a long time since you've done this, but here's how it works. We have our x1 and y1, and we have m. We're going to plug that stuff in and then solve for y, get y by itself. It's not hard. So we're going to plug these things in. So I know that my y is 2. So it's going to be y minus 2 equals negative 1 is my m, x minus negative 2. Now those two minuses make a plus. So I'm just going to go ahead and erase that. Two negatives next to each other make a plus sign. Alright, I'm going to hit about 20 minutes, it looks like, on these videos. I'm sorry it took so long, but this is a big one. First thing I need to do before I move this 2 over there is I need to distribute this negative 1. So this is going to be y minus 2 equals negative 1x minus 2. Negative 1 times that is that. Negative 1 times that is that. Next time I write this, I'm going to get rid of the 1 there, because you don't really have to have that. So it's going to be y, if I add 2 to this side, that'll go away, but I have to add 2 to this side. So for that, if I add 2 to negative 2, it just goes away. So it's y equals negative x. That is the answer to this. Okay, this 2 here just goes away. I add 2 to this side, add 2 to this side, both those negative 2's just go away. And negative 1x just becomes negative x. As for this one, here we have our slope of this one. We're supposed to be perpendicular. Well, perpendicular means that our slope would be negative, because that's positive, 4/3. Okay, so now I need my points, and I'm going to use the same formula. Y minus y1 equals m times x minus x1. My my y1 is going to be 1. Y minus 1 equals, my m is negative 4/3 times x minus my x1 is going to be negative 3. And again, those two minus signs make a plus. I'm going to go ahead and fix that. There's enough minus signs in here, it's going to be confusing. I don't need any more. Okay, first thing I do is I distribute this negative 4/3. So I would say y minus 1 stays the same. Negative 4/3 times x is negative 4/3 x. Now, you might need a calculator for this, but I know that if I multiply 4/3 times 3, 4/3 times 3 is just 4. Negative 4/3 times 3 would just be negative 4. And then finally, I need to get y by itself, so I need to add 1 to this side and add 1 to this side. So y is going to equal negative 4/3 x, and if I add 1 to minus 4, I get minus 3. Somebody left their phone in my class. Sorry about that. Okay, so those are the notes. Again, sorry they took so long, but it's a big page of notes. You had all weekend to do them, though. So take care. Hope that works out for you, and we'll talk more about this in class.